next, and not waiting much more time, we have Bruno Rodrigues. So in his pet is a codfish. Oh no, sorry, that's his favorite food. He once had a fish called Dragão, so I think you can guess what is his favorite football team. He loves to play CS. He says that he has created so many incidents that he has lost track of them. On the other hand, he also says that he creates some very cool things to balance. Okay, he's going to talk about client push and client pull and client push. I have no idea what this means besides physically, in my mind, physically pushing and pulling clients around the store. And well, I don't think this is a very good policy at the moment with a social distance thing. So let's wait a little moment, and you will join us just right after this. Thank you.
Hello everyone. Once again, welcome to this Tech Day, and now welcome to my talk. My name is Bruno Rodrigues. I've been a backend developer at Mindera for 3 years and a half now, and so I was asked to do this backend talk. Unfortunately, I will also speak about some front-end stuff. I'm sorry about that. And for this presentation, I wrote some HTML code. So I wrote a website. As I said, I'm a backend developer, so sorry for my poor front-end skills. And with no further ado, let me pull up the talk. Okay, so during the next 25 minutes, I will talk about the difference between approaches of using client pull and server push technologies. I will explain after this what this actually means, and then I will talk about 4 patterns or techniques that you can use for this, and they are polling, long polling, server-sent events, and WebSockets. I will explain all of them, and also I will do a demo afterwards. I hope that it will work. And in the end, I will basically have a conclusion and explain to you guys how you should choose between them if you decide to use one of them. Okay. So first of all, why is it even necessary to have a talk like this, or why do I think it is relevant, right? So usually we backend developers, we are the ones closest to the data, right? So usually there are backend developers, they do servers or services, and they expose HTTP endpoints or an HTTP API for the front-end team to consume on our clients. And our clients may be a browser, a native application, a desktop application, whatever you want. And the problem that backends face is that the data is constantly changing on the database. Either it is user input, let's say you go to your website and you change your email account on your account profile, or you have data feeds from third parties or any other entities that are changing the data you have stored. Let's say that, for instance, you have an application, and in that application you show the live score for football matches. Probably you are consuming a feed from Premier League or something, and so the data that you are storing is changing on the database. And the problem is that that data needs to reach your client, and it needs to reach your client as fast as you can. So you want your customers to have the best user experience. So the fastest the data gets to the client, the better, right? And so there's mainly 2 groups or 2 categories that you can choose to implement, right? So you have client pull, in which the client, the browser, or the application blindly requests data from the service, and in this section there it is included polling and long polling, sorry. And on the other hand, you have server push, in which your server is capable of detecting the changes on the database or in the data, and is proactively sending data to the client. And in this section, I will mention server-sent events and WebSockets. Okay. Now let's start with polling, right? And what is this? Polling is basically a technique in which your client asks for data regularly, either at a fixed rate or a variable rate. So let's say that every 10 seconds I call an HTTP endpoint to fetch the latest value that is stored on the database. Okay, and the server immediately responds with the data that it has stored on the database or on a cache or something. and so the client is not waiting for the data. But remember that the client is blindly pulling for the data, so it's blindly requesting data, so it has no idea if the data changed or not, so it might even get a repeated value that it already has in memory, okay? It's not very intensive on the server, this technique, if you are polling with an high delay. Let's say you poll every 10 minutes, it's very different than to poll every second, right? And of course, it also matters the number of clients you have online in your application. Also, if you are polling every 10 minutes, for instance, and your data changes every minute, there are some data points that your client won't see, and you'll have a bad user experience for them in your application, right? And of course, you don't want that. Okay, let's move on to long polling for now. So it's still in the group of the client pull techniques, although long polling tries to mimic a server push technique, okay? And what it happens in this one is that the client still opens an HTTP request to the server, but instead of responding immediately, the server hangs the thread and blocks the connection, okay, the response, until it has a new response. So it might take a while for you to get your response, and maybe your HTTP request takes, I don't know, 10 seconds, 30 seconds, depending on how often your data is changing, right? Because of this, it's very CPU intensive for the server, and it's also it's not very lightweight, right? So every time you want to get new data, this also applies to polling as well. You need to re-authenticate and reauthorize, so you need to send all the headers or the filters, and the envelope for an HTTP request is not that little, so there is a bit of an overhead, right? A good thing about the long polling part is that it works in every browser, so it's just a typical HTTP request, but the trick is on the server, right? So it works in every browser, and as you can see as well from the diagram I created, there are some data that might be missed during your reconnection time, right? Let's say that in between you're getting data and you opening the next request. If the data changes there, probably the server won't notice that new data was generated for you, and you won't get that data point, so you need to wait for the next one. Also, a difference from this diagram to the last one, you can see that below the server, here I have something new, which is that this server needs to be capable of detecting changes on the data, right? And before it didn't need to, because we just fetched the latest data that we had on the database, and now we need to actively detect changes. Either you do this by polling your database, for instance, or you can use something like Redis notifications, or there are other databases that have some stuff like that, so you can already use, and it works well. Okay, now let's move on to the server push approaches that I chose to show you guys. The first one is server sent events, and you can now clearly see that it is a very different approach from the other two I shown before. So the server sent events, basically, it's still HTTP. The client still makes an HTTP request, and the only thing that is really different from a normal HTTP request that we are used to is the content type. As you can see, for server sent events, the content type is text event stream, and okay, the name says it all, right? So we are expecting an event stream of type text, and basically the client still speaks with the server because it needs to make the request, which is the green arrow, and then every time there is new data, the server pushes that data using the event stream, right? So after that point, the client never speaks with their server again. It just waits for events, okay? Server sent events allow you to give basically a type or an ID to your events, so you can send multiple events through the same request. Let's say that you want to listen to profile events, and then, I don't know, football matches events. You can send them all through the same request. Okay, they are very easy to implement, so it's very similar to HTTP. You don't need to learn lots of things. Basically, all the tricks are done at the service level, at the server level. Disadvantage of this is that they only allow one-way communication. So after you open the request, you can't really talk to your server again unless you make another HTTP request, like a post or a put if you want to send data. So after the request is opened, you can only receive data. Okay. They have a reconnect mechanism out of the box, which is very good. Let's say that you have an HTTP timeout in all of our requests of 2 minutes, for instance. Every 2 minutes, your request would be made again, so you don't need to handle that part. Okay. Also, they are implemented in most browsers. I gave a little check yesterday. I think that only Internet Explorer doesn't allow to use server-sent events, and all the others allow. So they are well adopted. Okay, for the last one, I want to talk a little bit about WebSockets, and these are the most different of the 4. Okay, so all the other 3 they use HTTP. WebSockets is a totally different protocol, although it's still compatible with HTTP. So let's say that you have proxies or an API gateway or a load balancer in between your client and your server, it would still work. Okay. And also the handshake phase is HTTP, and I will be able to show you that in my demo. Also, you can see that on this diagram there is now a new blue arrow which says send data. So contrary to what I showed you before in server-sent events, with WebSockets the communication can happen 2 ways, right? I can receive data from the server, but after opening the connection I can also send data to the server, and that's a big plus for WebSockets. Okay. They are very difficult to load balance because let's say you have 2 instances and you have 1,000 connections to those 2 instances and they are being overloaded, and you just need to spin up a 3rd instance. It will be very hard to load balance those 2,000 connections across those 3 instances because you have persistent connections, right? So basically a tip would be to, I don't know, close the connections every now and then and wait for them to load balance across all your instances. WebSockets are also a bit more complex than server-sent events because it's a different protocol. You need to do more stuff to make them work, but they are still a good approach. Also, if you don't exchange too many messages, or you don't need to speak from your client to your server at all, use server-sent events. Okay, don't use WebSockets. Let's say that you actually need to speak with your server, but you only need to do that like once a minute or something. Maybe it is worth to do server-sent events, and when you need to send data to the server, just do a normal post request or a put request. Okay, now let's move on to my demo. Let me open the inspector tools. I'll be showing that. Okay, cool. Okay, so what I did for you guys is I implemented an API which implemented all the 4 techniques I showed before. So I have an endpoint to use for the polling. I have an endpoint that implemented long polling. I implemented server-sent events and WebSockets. What my service is doing is that every 1 to 5 seconds, I just choose a random number, I'm generating a new number, okay? And that number comes along a timestamp. And so I'm just randomly generating that number, and that number is the one you see here in gray, okay? So, and that is actually what I want my client to see in production, okay? So my website is just showing this number. And the first approach I'm showing you is the poller. And as you can see in the blue chart, I'm polling every 2 seconds for the data. And if you notice, you will notice that the green chart updates first than the blue one, okay? Because the green one is using WebSockets, is much faster, right? So the poller has no idea that the data has been updated, and because of that, you can see there is some delay in the data, right? Because that number might have been generated like 2 seconds ago or 3 seconds ago, right? Now let me show you 2 problems of pollers, sorry. Okay, let's say that instead of 1 to 5 seconds, I generate my value every 10 seconds to 12 seconds, okay? What will happen is that the poller has no idea that my data is not changing, but it's still making the request, so I'm always getting the same number. Also, you can see that because the delay is increasing, I'm always getting the same number along with the same timestamp. So I'm just doing meaningless HTTP requests. I'm just wasting resources, I'm wasting bandwidth, I'm wasting CPU, and in the end I'm wasting money, right? Because probably I'm running in the cloud, and the cloud is expensive. So this is not a very good approach for this use case, right? On the other hand, and now let me switch this to maybe 800. Okay, now I will generate values much faster, and you will see that the real one, the real chart in green, it will update much faster than the blue one. And also, if I freeze chart, you will see that the blue client didn't get all the values. Okay, there were some values that he missed, and this might be important. Let's say that you have a website, just like eBay, for instance, and you have your client bidding an item, and he sees that the item costs $100, for instance, and you are polling every 30 seconds, for example, and when the HTTP request runs again, it fetches the value and the value is already 200 and is thinking that maybe someone is crazy because it just doubled the price of the item. But maybe because he missed some biddings along the way, um, maybe it was like 10 increments of $10 and not one increment of 100, but he has no idea because you're not showing him that, right? Or also the user experience that he's having is not that good, okay? Okay, that's it for the poller. Let me just show you what the poller request looks like. So basically, there's nothing new here. I'm just doing a get HTTP request. Okay, I'm using JSON and I just have a response, and my response is the number and the timestamp. Okay, so there's nothing new here. I don't think it's rocket science, right? Okay, now let's move on to the long polling, and let me reset all my values. Okay, cool. The long polling, as I said, is trying to simulate a server push technique, right? So as you will notice, the delay is not much, right? So I open the HTTP request, and as soon as the server has a new data point, it will just push that number to my client. So the delay is very low. I'm not missing any data, and also let me freeze. If I check and I compare the long poller with a WebSocket, the chart will be the same. Okay. So they are basically getting the same data and the delay is very low. But I'm blocking a thread on my server, and so if I have 1,000 clients, maybe my service won't work very well, right? And for that, let me show you what a long polling request would look like. So it would be the same request, a get. I have, of course, a different path, a different endpoint, and I also have my response. But the biggest difference is that instead of taking 4 milliseconds or 1 millisecond, it takes almost a second. And maybe if I'm lucky enough, I will get some requests that are taking almost 2 seconds and 4 seconds. Of course, if I increased the interval in which I'm creating and generating new numbers, of course, this time would increase a lot, right? If I'm generating numbers every minute, the time could go as high as 1 minute, right? Okay, I guess that's it from long polling. Let's now move on to server-sent events. As I said, now you won't notice many differences between the charts, so the delay is still pretty low. I don't know, it's almost 0 seconds, okay. I still get all the values, and now let me show you what it looks like. Okay, so as you can see, instead of having multiple requests, I now only have one. So the first one is just an image. So this one is actually the request for the events. You can see that it is not finished yet. So actually the browser warns me, caution, request is not finished yet, right? So this request has been opened for 6 minutes since I basically refreshed the page. And you can see that I no longer have a response tab. Okay, I have an event stream tab, and in this event stream tab I get all the numbers, all the updates for those numbers that I'm requesting. Also, you can see that my updates, they have a type, as I said, so you can have multiple streams of different types, and then you can have an handler on your front end for each one of these types. Of course, I'm only getting number updates, so we won't see any other type in here. And if I show you the headers part, so the request response part, you will see that everything looks like the polling or the long polling, and the only difference is the content type. Okay, so everything else is the same, but instead of getting, I don't know, the common application JSON, I'm getting an event stream of text, and of course that text can also be JSON. I'm sending JSON as my events. You can do whatever you want. You can send YAML, JSON, I don't know, comma separated values. You can do whatever you want, okay? And I guess that's it for server-sent events. Let's now move on to WebSockets. Okay, once again, the chart is the same. You get all the values, almost no delay. And let me show you what a WebSocket would look like. Okay, my inspector tools are really slow because I have lots of requests. Maybe I'll just refresh my page. Okay, sorry about that. Okay, as you can see, right now this is what a WebSocket request would look like. You may notice that the request URL, if you never used WebSockets, is a bit different. So you don't have HTTP or HTTPS anymore. We use WS, which stands for WebSockets. You also have WebSocket Secure. And you will have a bunch of custom headers for WebSockets that are defined in the RFC. Of course, because of time constraints, I can't speak and explain them all. If you are curious, you can just check the RFC or some other docs. And also you may notice that I'm no longer get a 200 OK, I get a 101, 101, sorry, switching protocols, because I want to speak in a different protocol. Okay, it's not HTTP anymore. I want to speak basically WebSockets. And I also no longer have a response or event stream tab, right? I have a message tab. And in this message tab, you can see everything that's going through the socket. And remember, I said that the communication works both ways now. That's why we have the red arrow. Okay, so basically this means that I'm only receiving updates. The updates look just like the same for the polling or the server-sent event. So it's a JSON, it has a number and a timestamp, and I'm getting a bunch of updates. Because of the two-way communication, I can actually show you how we can use this. Let's say that while I'm browsing these numbers on my website, my client decides that he no longer wants numbers that are lower than 5. So he can just send a message to the server, and you can see here in green that I sent a message to the server, and I told the server, okay, I'm no longer interested in numbers that are lower than 5. Just give me updates for numbers that are greater than 5. Of course, you could do this in your application, your front end. You could just filter out or ignore those values. But you are more clever than that, right? You know that it doesn't make any sense to receive data that you won't show to the user, right? It was a problem in the polling, so you want to do the same. So and if I can change this whenever I want, right? I send a 1 and now I will start getting updates for other numbers. So I just got a 4 as well, so it is working. So that is a big advantage of the WebSocket. So you can exchange data from one side to the other, and you are not limited to updates from the server. Okay, I guess that's it from my demo. Let's move on. So now, what would you do, or what I think, or what are my advices if you decide to go with something like this? Okay, first of all, maybe check other approaches, right, that I didn't mention in this talk, so I didn't show you the entire world. There are other stuff like RSockets or something, so you can just check different approaches and do some proof of concepts, right, and test your different needs, maybe benchmark your services and see if it fits the need you want, because there are plenty of solutions for what you have, right? And don't jump to something just because it is cool, right? I probably now you can tell that I'm a big fan of server push technologies, and I am, but you shouldn't just use them just because it's cool or more fun to implement, okay? And maybe you can jump to the next topic, which is maybe a poller could work in some cases, right? And it's not bad to use polling as long as it works for you. So let's say, for instance, that you are running a weather website, for instance, and you are showing the live weather in your city. Maybe that temperature, and if it rains or if it's sunny, maybe that only changes like once an hour or twice an hour, right? And it would be pretty stupid to poll for that data like every minute. But if you poll it like every 10 minutes, maybe it's okay, right? Maybe your clients are only in the website like for 1 minute, and you only need the poller for someone that leaves the tab open on the browser, okay? So yeah, polling might work for some cases. It's not that bad, okay? It has some problems. As long as you are aware of them, you can use it. Okay, now long polling. I just mentioned it in this talk. I almost didn't mention it because you shouldn't use it. Okay, long polling is just trying to simulate server push, and it does a very bad job at it, right? So you have other approaches that are much better than it to do basically server push, right? And then between the other two, if you don't need to communicate at all from your client to your server, just go with server sent events. Okay, they work pretty well. They are really, really easy to implement. It's not rocket science. And if you have two-way communication, or if you need to send lots of data from your client to your server, let's say that you are implementing a first-person shooter, of course you need to receive lots of data and also send lots of data. So WebSockets would be a very good pattern for you. Also, another cool thing about server push technologies is that eventually your services need to start being aware of changes in the data, right? And so you will eventually start using a more event-based approach, and you'll probably add a RabbitMQ broker to your system or a Kafka broker, and then you can do lots of cool stuff with events, right? You can react to events and have some alerts, monitor stuff. You can do whatever you want, and events are really useful. Okay. And that's it from my talk. If you guys want to discuss something I mentioned or something I didn't mention, feel free to send me an email or contact me on LinkedIn or any other social network in which you find me. And let me see if we have some questions now. Okay. Okay, we have a question from Raul. The question is, using WebSockets, do you write your own protocol on top, or do you reuse something like a message queue to handle everything? Okay, that's a good question. So right now in production, I'm using the GraphQL WebSocket protocol. So I didn't implement my own, but yeah, I'm using a custom one. And yes, you should create a protocol if there are none that fits your needs. I know that there are some, like Stomp, you may use it. It already defines how you should define your messages and your events. If there aren't any other that suits your needs, just create your own, and that's it. And okay, I think there are no more questions. Thanks a lot, guys, for joining me in these, I don't know, 25 minutes. I hope to see you soon at our offices. Have a nice day.